All right, let's talk about something huge. We're going to demystify a technology that completely changed the game for handling massive, and I mean massive amounts of information. We're talking about Hadoop, the open source framework that basically tamed the beast we called big data. Just think about it for a second. Our entire world runs on data now. Every time you click, every purchase you make, every sensor out there, it's all generating information. And you eventually get to a point, a wall really, where a single, even super powerful computer just can't store it all, let alone process it. That right there is the big data problem. And this is the solution that came along. Say hello to Hadoop with its friendly yellow elephant logo. At its heart, Hadoop is a framework that lets you process these enormous data sets using clusters of, regular off-the-shelf computers. So the whole idea is it's not about having one giant supercomputer, but about getting hundreds or thousands of normal computers to work together as a team. Now this right here, this is the secret sauce. This is the core genius of Hadoop. See, the old way of doing things was to drag these giant piles of data, we're talking petabytes, from where they were stored over to a powerful processing unit. It was slow, it clogged up networks, it was a mess. Hadoop just flips that whole idea on its head. It says, hey, why don't we just send the little bit of processing code to the machines where the data already lives? And that fundamental shift is what makes the whole thing work so beautifully. So how does it actually do that? How does it pull this off? Well, the magic behind it all is a programming model called MapReduce. This is the engine that powers the whole thing. So let's pop the hood and break it down. This diagram lays out the whole process perfectly. It's basically a data assembly line. You start with your huge input file on the left. Hadoop automatically chops it up into these smaller, more manageable chunks. Then each of those chunks gets processed in parallel during what's called the map phase. After that, the results get shuffled and sorted, and finally, they get combined in the reduce phase to give you your one final answer. It's a classic divide and conquer strategy. Okay, let's zoom in on that first step, the map function. This is the real workhorse of the operation. It takes one of those small chunks of data and just transforms it. The analogy here is perfect. Imagine you give a small stack of books to every single librarian in a city, and you tell them your job is to go through your stack, and for every word you see, just put a little tally mark next to it on a notepad. They're all working at the same time, in parallel, which makes the whole process incredibly fast. Right, so all our librarians have done their part. Now what? That's where the reduce function steps in. Its job is to take all that amazing parallel work and bring it all together. So the head librarian comes along, collects all those notepads, finds all the entries for a single word, let's say the word data, and then just adds up all the tally marks from all the different notepads. It synthesizes everything into one final neat answer. Okay, I know this might still feel a little abstract, so let's make this super concrete with the most classic example in the big data world. It's kind of like the hello world of Hadoop, counting words in a gigantic text document. And the logic is it's beautifully simple, really. The map task just reads through the text, and for every single word it sees, it spits out a simple pair, the word itself and the number 1. That's it. Then, the reduce task comes along, gathers up all the pairs for a specific word, like the, and just adds up all those ones. And here you can see what that mapper logic actually looks like in action. Don't worry too much about the code itself, just focus on what it's doing. It takes in a line of text, breaks it down into individual words, and for each and every word, it outputs that simple pair, the word and the number 1. And here's the second half of our dynamic duo, the reducer. It gets a key, which is just one unique word, and it gathers all those little ones that the different mappers generated for it. It's like a funnel, right? It just collects all those individual counts, adds them up, and boom, out comes the final total count for that word. Simple as that. Okay, so we've got the logic. We know how to count words. But how does this program actually run on a cluster of, say, 100 or even 1,000 different machines all at once? Let's look at the anatomy of a Hadoop job and see how it all gets put together. You gotta understand, a Hadoop cluster has this kind of master-slave setup. At the top, you have the master nodes, the brains of the operation. This includes the name node, which is like a master librarian who knows exactly where every single piece of data is located. It also has a job tracker, which is like the project manager that delegates all the tasks. And then you have all the slave nodes. These are the data nodes, the actual bookshelves that hold the data, and the task trackers, the worker bees that actually run our map and reduce code. So, when you want to run your word count program,
You package everything up, your mapper code, your reducer code, and a little bit of configuration into what Hadoop calls a job. Think of it as a self-contained little package of work that you just hand off to the cluster.
And the moment you submit that job, this amazing automated process just kicks off. Your computer sends the job to the job tracker. The job tracker immediately calls up the name node to find out exactly where all the chunks of data are living. Then, and this is the key part, it assigns the map tasks to the worker bees on the very same machines that are already holding the data. That's moving the computation to the data in action. From there, the cluster just takes over, runs all the tasks, handles any failures, and spits out your final result. So when you step back, Hadoop was an absolute game changer. It truly laid the foundation for the entire big data ecosystem that we have today. But, technology never stands still, does it? Hadoop was perfect for solving the massive batch processing problems of the last decade. But it leaves us with a really interesting question to think about. As data gets faster, more complex, and more tangled up with AI, what new tools and frameworks are we going to need to tame the data beasts of tomorrow?